for a recursive function, if we have, sorry, include stdio.h. Okay, so how do we kind of initialize a function? Int recursive function, and let's say it gets 2 integers, right? The same thing with recursive functions. There's no difference here whatsoever. Even when you use it in the main, it's basically the same thing. You have a is equal to recursive function AB, for example. You call it in the exact same way, and the function definition is also the same thing. So you just have just dummy variables int a. We did this in the last class. I'm just kind of reminding you guys. X and Y. Just to kind of let you guys know that when it comes to the format between recursive functions and normal functions, there's really not much of any difference. Now, where the difference comes into play is in recursive functions, you actually call the function somewhere inside the function itself. So for example, you would have inside the function, you can have like any y is equal to recursive function I and v, for example. So you can see that inside the function itself, we're using, and then you say return y or whatever. This is a basic definition. It's not a proper program. I'm just trying to let you know that the format is the same, you know, with the way we define, initialize it and call it in the main, and also define it. It's all the same thing. Difference is recursive means we kind of use it over and over again, and it's recursive inside the function. All of this is just theory, and let me give you like an example. So for this class, or for this lab rather, we're going to have 3 experiments, right? The first experiment is we're going to use an iterative function. That's the one you've been used to, which is just a normal function. You don't call the function inside itself. We're going to use an iterate function to sum the numbers from n to m. All right. So, all right. I'm going to go a bit slow on this part in case anyone didn't understand me in the last class. All right. So we have the function definition, int iterative sum, and we have 2 ints because it's going to get n and m, basically 2 integers. That's why we have int, and that's just the initializing. Then we go into the main. No need to worry about this void. You can leave it empty if you want. So we go into the main, and we initialize n and m because we want to save the value. So that's just integers. And of course, we have somewhere to save our summation as well. We need to save the result somewhere so we can print it. And then again, we just have a printf. It says enter n and m respectively. Okay. Here's one thing, just a small tangent that I need to go on. I saw in some homeworks, okay, some students, I think you were asked to enter, you were supposed to ask the user to enter the height and the radius for the previous lab, homework. Some students did it like this. They were like, enter height and the radius. And then they did scan. Okay, so see what happens is if you don't add respectively and you just say enter height and radius, I don't know which one is, you know, what the order is, or the user wouldn't know which order to enter the variables, like to enter height or the radius or whatever, and wouldn't know which one is which. So my advice is, of course, if you have multiple variables, try and use like maybe multiple printfs, like enter n, use a scan, and then enter m, use another scan. Or if you really have to do it, you know, together, then make sure you add respectively, or make sure you state the order in which they enter. So you can say enter radius first and height second. That way the user would be able to know how to kind of interact with your program. All right, so far so good. Just coming back to our program here. So it's just a simple printf and scan to save whatever you enter in, whatever you enter, it's going to save that into N and M. And then we have the calling of the function, which is just iterate. The name of our function is iterative summation, kind of long, but anyway. You just call it iterative summation, you pass N and you pass M, and that's it. This function is going to give you the sum, and it's going to, yeah, it's going to give you the sum, and that's just going to be equated to summation. And printf, the summation is blah, blah, blah. You're just going to print the summation. So let me just show you how that kind of runs before we go into the function. You have N and M. So let's say N is 0. We want it to add from 0 to 3, let's say. So summation of numbers from 0 to 3 is 6. So that's 0 plus 1 plus 2 plus 3. So that's 6, of course. And that's kind of how the program works. So now how does this function iterative summation work? So far, so good, right? Everyone's kind of following me. Oh, mistake. Okay, so how does the function iterative summation work? We come into the function. Of course, it redefines a variable for the sum, which is going to be returned to the main program. Like I told you before in the previous class, anything you define here has nothing to do with the main, and anything you define in the main does not affect the function. So for example, if you define in summation here, you have to redefine it here again if you want another place to store your sum. So they redefined it, they said in sum, and they equated it to 0. And then they said for I, they defined int I here. I like defining it outside, but you can do it like this as well. For int I is equal to, okay, they're using from and to. Okay, so int I is equal to from I less than or equal to 2 I plus plus. Basically, from is N and M. Just to make it more obvious, I'm going to change this to N, sorry, and this to M. Okay. And for I is equal to, it starts at N, which is 0 in the short example I just showed you, and M, right. So it's basically, the loop is going to start from 0 to 3 in this case, in the case of our example, basically from the beginning to the end. And what it's going to do in the loop, it's going to add the I to the existing sum. So sum starts at 0, right? So we have sum is equal to 0. This sum is 0. Then I would be incremented, I plus plus. The I would be 1, so it would be 0 plus 1, and then that would be equated. And now your sum would become 1. And then the loop goes on again, and then it would be 1 plus 2, then 2 plus 3, and so on and so forth until it gets to M. M is 3, so once it gets to M, it exits and it returns sum. Very straightforward, very easy. Does anyone have any questions with this function? I hope it's clear. Wait, hold on. Does anyone have any questions with the so far?
No, sir, it's clear.
Oh, my volume is low. Sorry, what did you say? Is it okay?
Yes, it's okay.
Okay, great. All right. So that's how you do it with iterative functions. So far, this is kind of just revision. We already know about all of this. Now for this lab, the next experiment, it says change iterative summation function to recursive. So we're going to do the exact same thing, but this time we're going to do it with a recursive function. All right. So like I told you before, the recursive function is basically the format is the same thing as the iterative sum. Iterative functions. Yeah, that's the word. All right. So again, we have the initialization of the function, int recursive function, blah, blah, blah. And then you go into the main, initialize the N and M. Same thing we did, summation to 0. Nothing changes here because all that changes is the function we're actually using. The summation is recursive. That's the name of the new function that we have. I changed this to N and M in the last class, but anyway. Okay, so it's gonna print the same thing and we're done. Now what's different is it's a function right here. Now I need everyone to focus because this is quite confusing at first at least. All right, so how does it do the summation using a recursive function? So what it says is if n is equal to m, by the way, this equal is the equal of comparison. Sorry, give me a second. Okay, so if this, like I was saying, the equal sign this, you have to put this if you're trying to compare two things. If you're trying to compare n and m, like n and m, if you're trying to see if they're equal, you use the double equal sign. If you used only one equal in this if, it will equate n to m. So that would be that we don't want that. We don't want it to equate n to m. So do not make the mistake. Always, if you're trying to compare two things, you have to put double equal in programming in general. So anyway, it says if n is equal to m, return m. Okay. But if it's not, then return n plus recursive function. You call this the same function again, n plus 1 m. So how does this work? Okay, it says, I think it would be best to use an example, all right? So for example, we have, let me put as a comment, we're gonna start use the same example we did before. N is equal to 0 and m is equal to, let's say 2. 3 is kind of long, so let's say m is equal to 2. All right. So in the first instance, let's say it comes in here. It says is 0 equal to 2? It's not equal to 2, so it's gonna skip that. It comes here. Return n plus recursive function 1, 2. So what does it do? It says our solution, basically summation, the sum is equal to n plus, let me do it, n plus the recursive function n plus 1. All right, the recursive function of n plus 1. So n plus recursive function 1, 2. So this is the first step. We'll call this, let's call this A1. Or we can just put 1. All right, the first step, this is what it's going to do. It's going to say the sum is equal to n plus recursive function 1, 2. Now, okay, n is actually 0. So I'm just to make sure you guys understand the equation, I'm going to put 0 here, but only for the first one, of course. Now, in the next step, it needs to find this. Because we called the function again, it now needs to find what the recursive function of 1, 2 is. So it's going to run the same function again inside itself. What does it do this time? Okay, it comes here, it checks. Our n is now 1 and our m is 2. It says, is n equal to m? No, and 1 is not equal to 2. It's going to do the same thing that we had before. So now it's going to say recursive function of, let's call this, let's call this someone or something. Okay, you know what, let's just use it like that. All right, so it would say recursive function 1, 2 is equal to 1. Remember, our n is now 1, right? Because we're using recursive function 1, 2. So it's 1 plus recursive function 1 is 2 and 2. So it's going to pass 2, 2 this time. All right, so it does the recursive, it calls the function again. All right, so now we have the third step. We need to find what recursive function 2, 2 is. All right, so where am I? Just copy. All right. So when we come to recursive function 2, 2, what does it do? Now our n is 2 and our m is also 2. It says if n is equal to m, return m. So since n is equal to m, recursive function of 2, 2 is just equal to m, which is just 2, right? Does everyone understand this? Okay, so this is good. All right, so now what's going to happen? We now know that this recursive function 2, 2 is equal to 2, so it's going to put that in the original one, right? Because it says return this. 1 plus this is 2, that would be 3. And then it puts this here, and that's 0 plus 3. And so your sum in total would be equal to 3. All right, so this is basically the solution for this is 2. The solution for this would be, then it would become 1 plus 2, right? And which is 3. And then it would come here. The solution for this is 0 plus 3, which is equal to 4, and so on and so forth if they have more differences. It's kind of confusing at first, but does everyone get this so far? Do you want me to explain it again? Because it's quite confusing.
Yeah, teacher, can you explain it again? I'm very lost.
Yeah, okay, yeah. I mean,
Me too.
Yeah, I expected that. Okay, so a way that helps me actually understand the recursive function is you think of it as to have like a forward path, a forward pathing or propagation or whatever, and a backward pathing. This is just the personal way of me finding it out. So the way recursive function works is you keep calling the function over and over and over and over again until it ends, until the end condition happens, which is this, if n is equal to m. Once that end condition happens, it starts going backwards because it says return m into this one, right? And then it's gonna return this into the previous function, and then it's gonna return that one. So it kind of goes backwards. So if I had to kind of re-explain it to you guys, so we can use the same example, n is equal to 0, n is equal to 2. Let's say for star forward path. Let's say forward path. All right. So the forward path. All right. It's gonna say we're using the same thing. N is equal to, you know, let's make it smaller, more compact. N is equal to 0. M is equal to 1. Or no, you know, let's use 2. 1 is too small. All right. So for the forward path, it's gonna say we have sum for the first thing. It starts with the function n is 0 and m is 2. All right, that's standard. And it comes into the function, it runs the function. This is not equal, so it skips this. 0 is not equal to 2. And then it comes to the else function. Right? You don't have to put it in the return. You can kind of make it as its own line, but they just kind of shoved it together. But basically what it says is return n plus recursive function n plus 1m. All right, so the first thing is just sum is equal to 0 plus step 1. Okay, so 0 plus the next iteration. So we can call it 0 plus I1, if that's big enough for you guys to see. Or S1, let's call it S1. 0 plus S1. Okay, now that would be the first iteration, and then now S1 is basically recursive function of blah 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 blah. And what does it say? S1 is you call the next function by adding 1 to n. So it would be recursive function n plus 1. So S1 is equal to recursive function right here. Actually, it's just this. S1 is just this, so no need to write that again. Right, so S1, now for S1 we have n is now 1, right? N is 1 because we added 1 to the n, sorry, and the m is the same. So it checks here, they're still not equal. And what does it say? It says return n plus 2, 3. All right, so it would say return, our n is now 1, plus, and then you can call it S2, the second calling of the function. Okay, you can just call that S2. All right, so this is all just in the forward path. Okay, and then we have S3, which is equal to, of course, it's just going to be 2 plus, let's do it. So S3, this time our n is, no, for S2, our n is going to be 1 plus 1. So that's 2, and our m is 2. So they're equal now. So what is it going to return? When it runs this function again, it's going to return m, right? It's not going to do this again because they are now equal and this is satisfied. So our S3 is just going to be equal to 3. 3? No, 2, sorry. Our S3 is just going to be equal to 2 because 2 is equal to 2, return m, and that's just 2, no addition, nothing. All right, so and then that's it. The recursion stops. Okay, so you've gone to that's the end of the forward path. Now, what happens with recursive functions, what's special about it is they kind of go backwards, all right, into each other. So you have the backward path, let me call it, right? How is that going to work? First, you have S3, and it says return. Let's say this is S3 now. It would S3 basically says return m, and you're returning it into sorry, this should be S2, not S3. Yeah, you're returning S2. You're returning it to S2. You're returning m to S2. All right, so basically S2 is equal to 2, and then you have 1 plus S2. All right, so S1, or you can start with S2 as well. You say S2 is equal to 2, that's done. All right, then S1 needs 2, right? So S1 is equal to 1 plus 2, for example. All right, and see how it's kind of like going backwards. So we started at S2 is equal to 2, then S1 is equal to 1 plus 2, and then the sum is equal to 0 plus S1, which is 3. Let me equate this to 3. 0 plus 3, and so the sum is, sorry, 0 plus 3, which is equal to 3. All right. Okay, so do you guys kind of understand how this works, or are you still confused?
Hello.
Yes.
Sir, we can do other solution because.
Sorry.
Okay. We can do other solution about recursive.
You mean using the recursive? Yeah, you can. There are other ways to do the recursion for it.
So,
like if you want to.
For example, sir. Just we do a counter. Tamam?
Yeah. Okay.
Okay. So we do a okay. E.
Okay.
Okay. So counter is E to 1 to n, because for example you enter n is 3.
Okay. And then every loop you just call the function to kind of calculate it. Are you talking about what we did in the first one? Because what we kind of used there was we used the counter and we just added it to each other. That's an iterative function if you want to use a loop. Anyway, don't worry about it. There's an easier example right after this one that would hopefully make things a bit clearer. Don't worry, this one's like the way recursive functions are. Usually, if you didn't think it up yourself, it's a little bit harder to understand. But the good thing about the recursive functions is they make your program very short, and in general, they're very clean and compact, let's say.
Teacher, can you run the program? Can you run it so that we can see?
Oh, yes. Okay. Sorry, the comments here. Do I hand this? Yeah, same thing here. I have an infinite comment, so it said no. Yeah, that's another thing. You guys learn to write put comments in your code. I'll explain it at the end of the lab, don't worry. So this is the recursive function. It's the same thing. It's just going to sum things up. So we have the examples we used was 0 to 3, right? So n is 0 and m is 3. And as you can see, summation from numbers from 0 to 3 is just 6. It's the same thing, just with recursive function. Now for the next experiment, which is actually the last one, and it's very short and actually very easy. In my opinion, we should have done this first before these guys because they're kind of more complicated. But what it says is using a function factorial. Use a recursive function to kind of calculate the factorial of any number.
Excuse me.
Yes.
Do you mean the first and the second program gives the same results?
Yes, I just told you
the same, but
yeah.
the way is different.
Yeah.
Right.
Yes. The first code is just summation as well. They're the same code, but the only difference is the function. We're using iterative functions in the first one, and in the second one we use the recursive function. All right. Okay.
Okay.
All right. Good. Okay, so for this one, for this program, we just need to calculate the factorial of a number using recursive functions. And I'll show you. You can see like this is the whole program. It's very short and very easy to understand, and I'll kind of explain that to you. So as usual, we kind of just do the usual stuff. This is for a function, just definition. We go into the main. Int num, this is where we're gonna save our result, the number entered by the user. Long result is because, you know, factorials can kind of scale up really fast. So we put the answer, like we put it as a long type variable, even though the input is gonna be integer, the result could potentially be a very, very huge number. So anyway, we have, so just print enter number to view its factorial. Scan, you use a scan to get the number. What is this? Okay. This is just, if number is less than 0, number must be positive. You can't have factorials for negative numbers. That's nothing. We just need to focus on here. So when you enter a right number, a positive number, it's going to say result is equal to, and then it's going to call the function. So this is a function initialization. We call the function here. Print factorial, and that's it. All right, that's the end of the main. And yeah, you're pretty much done. Now for the function itself, wait, let me run this so you guys can kind of see what it does. Enter number to view its factorial. We have 3 factorial. Let's stick to 3. 3 factorial is 6. Like I think we did factorial before without using functions. Was that in the class or homework? Was that a homework or did we do that in the
class?
Okay, so we did it in the class. All right, good. So you guys know what a factorial is. It's just 3 times 2 times 1, and if it's 4 factorial, it's just times 4, blah, blah. All right. Okay, good. So we just need to do the same thing, but with a let's say recursive function this time. Now, how does this recursive function work? All right, so what it does, first of all, they kind of eliminated 0 and 1. You know, the factorial for 0 is 1, and that's the same thing for 1, but we can't add it to the main equation, because if we add 0 here, like 0 times anything, our result is just going to be 0 all the time. So this if is just basically just says if x is equal to, if the entered number is 0, or if it's 1, it's just going to return 1. All right. And it says return x times factorial x minus 1. All right. So I think if you're following, you probably already kind of see the picture. But let's say we enter 3, right? So let's say our number was 3. Our number was 3 slash star. Number is equal to 3, right? What is this program going to do? It's going to check, is it 0, 1? No, it's not 1 or 0. It's going to say return x times factorial of x minus 1. So it's gonna say factorial is equal to 3 times factorial of n minus 1, which of x minus 1, which is 2 factorial, right? And then 2 factorial is equal to, the loop comes back again, and this time x is equal to 2. It checks again, it's not 0 or 1. And then what does it say? Return 2 times factorial of 2 minus 1. So it would say factorial of 2 is 2 times 1 factorial. So when it calls for 1 factorial, it checks here and it sees if x is equal to 0 or 1, return 1. So it says 1 factorial is equal to 1. All right. So this is the forward propagation I was kind of telling you guys about, right? And now it's just gonna kind of send everything backwards. This was me explaining it to the previous lab. Let's just delete that. All right. So we have the backward. All right. So this time, I mean, I don't really need to make a list, but it's pretty obvious. You just have the 1 factorial is equal to 1. So it's going to replace this here with 1. And then 2 times 1 is equal to 2. Let's do it here. So you have 1 factorial is equal to 1. 2 factorial is equal to 1 times 1 factorial, which is equal to 1 times 1, which is, 2 factorial is equal to 2 times 1 factorial, sorry, right here. So we have 2 times 1 factorial, which is just 2. All right. And then we have the 3 factorial, which is just equal to 3 times 2 factorial, which is 3 times 2, which is 6. All right, so you can see that in the end, we're going to get 3 factorial is equal to 3 times 2, 3 times 2 times 1 times, well, not times, that's it. And if we have 4 factorial, it's going to be the same thing. It's going to start from 4 and 4, 3, 2, 1, and, kind of go back the same way as well. So does anyone have is this confusing? Should I re-explain this? Do you guys get this? In my opinion, this is easier than the previous one. Is this clear? Yeah, Mahdi? Sorry?
It's clear.
Yeah,
This one
okay.
it's clear.
Yeah, this one is clear. So, yeah, this one is quite easy
Not
because...
like the previous one.
Yeah, the first one is a bit difficult, but it's actually it's pretty much the same thing, except instead of multiplying, and we have one variable this time, and it kind of just multiplies here. Instead, it adds, and there's 2 variables. So, but anyway, this is how the whole how do I say it? Recursive function works. No need to be scared of recursive functions. Trust me, at the beginning they're hard, but later on they're so easy because you would kind of be of the mindset and you would be easily able to just kind of understand what the program itself does. But if you ever see a recursive function, okay, this is a kind of trick that I use, is what I explained here. If you ever see a recursive function and you don't understand it, just do exactly what I did here. Just start, get some sample number, okay, or sample whatever that's going into the function, and then test it, kind of forward propagation, all right, and you kind of just go with the recursion, or try and not pick something too big. We picked 3 here, so that wasn't too bad. Anyway, we picked 3 here, so that's fine. Don't pick something too big, just so you can understand what exactly it looks like. You just go forward and then you go backwards. And by the time you're done doing this, you'd easily be able to identify what exactly the program does. That's pretty much it for this lab. I'm gonna explain the assignment, but does anyone have any questions? You can ask me any questions. What's the time now? It's just 5:10. Like I said at the beginning, it's a very small lab because it's kind of like a continuation of the previous functions from the previous lab. So we didn't really have to talk about the definitions and all that stuff. But does anyone have any questions? If not, I'll explain the homework to you guys. Any questions? No?
No, lecture. No.
Okay, good. That's good. All right. Okay, so for the homework today, we actually have the easiest homework for this lab. This homework is very easy. Why it's easy is because, hold on, let me just, all right, I'll keep this. Why it's easy is because they've already given you the code. All right, they've already given you the code, and you guys should like use this as your template. I saw a lot of people from the previous labs. I mentioned it in the class. The first thing I want to see in the homework, we had what? Calculate, I think, volume or something. And you were supposed to use RH in the previous homework. And I told you the first thing I want to see in your homework was, the templates for the functions. So use the templates, they're there to help you. And, that's kind of what I look at the first time. Some people gave me with float, some with integer and all of that. So try not to diverge from the format. So kind of use the same thing that's used here. You can change A, to X, M to whatever. The variables don't really need to change, but kind of define your function using this. So what does the program say? It's like I said, very simple. It says, write a C program, which does the following. Write a recursive function to calculate the function given below. They already give you the entire recursive function. They say if m is equal to 0, n plus 1, if m is this, do this, if it's this, do this. I mean, type this in. It's literally, they give you the code and everything and how to do the recursion. And of course, there's going to be a simple user going to enter what m and n is, and that's easy. So, okay, so for those of you who are still a bit confused, there's not really much to show you in this, but what I want you to see is at the beginning, you can just say int recursive function, int n, int m, okay, it's fine like this. And in your main, you just have a printf, enter m and n. And then you have a scan to get those two. Don't forget, respectively. You have a scan to get your n and your m, and then you call the function. You just say, it says the result is going to be displayed on the screen, so you can say d is equal to recursive function nm, for example. All right, you can use whatever variables you want. Okay, and then you come in here, and basically you just kind of put in this into the recursive function. All right, you just use ifs. If it's this, if m is equal to this, do this. If m is equal to this, do this. Like I said, the homework is pretty much just kind of like copy paste because it's already done. Don't forget to print d at the end. But yeah, that's pretty much the homework. Now, what I do want you guys to do is, by looking at this, okay, you can't really tell what the program does. It's kind of confusing. I want you guys to kind of add a comment after the program is done, kind of telling me what you think the program does. Or if you, even after you run it and you use some examples, you still don't know what the program does, just show me the samples that you use. So say, for example, n and m, n is equal to 9. Don't use a big number. N is equal to 0, and m is equal to 3 or 4, for example. All right, and then you kind of work it out. You kind of work out how the n works, forward propagation and the backward propagation. But if you are able to figure out what exactly the program does, all right, I'm not going to tell you because that's kind of the trick. Just write it down in just a quick comment. Just let me know. All right, so like I said, I'm just going to look here for the grading and all of that. And the rest of it is very simple. It's the simplest homework you have. And I spoke to the lecturer today. You you have till the next lab, basically. Not the next lab, but like the next, when classes resume. So for the whole midterms, I think you have almost 2 weeks to do this, so you can take your time. You don't have to do it if you're busy with exams and all of that. It's a very short one, so it's better you do it quicker sooner than later, but either way, you just plug that in, and when you're done, you kind of just put a small comment here explaining what exactly you think the code does. All right, very simple. And does anyone have any questions? Anyone? About the homework, at least, how to kind of go about doing it. Osama, yeah?
Question.
Yes?
About the last homework. I had some mistakes, but I submitted it. Can I edit on my past homework?
No. Once the deadline has passed, I already have the kind of pre-saved files for that, so I can't change those anymore. So that's why you kind of want to submit as fast as possible. I'll give you a feedback on the mistake, and you have some time to change it. Don't wait till the last second to do the homeworks.
So I should do it again, right? And submit it again?
Have you already submitted?
Yeah, I submitted, but there's some mistakes.
Don't worry. Did I already give you a feedback? If I already give you feedback,
Yes.
then okay. You know what? We'll talk about that after the class. No problem with that. I'll just right after the class send me a message and we'll speak.
Okay.
Does anyone have any questions? Kind of related to the homework, for example, or this course? Or this class rather. Anyone? Is everything okay? Oh, yeah, I forgot to start the recording at the beginning. Whoever started it, thank you. I completely forgot. Okay. If no one has any other questions, then I wish you all the best midterms. Good luck, you guys, with your midterms. If you have any questions with introduction to programming, with maybe if you see a past question you can't solve or something like that, hit me up in the chat and I'll try and help you as much as I can. I try and help as much as I can. So, is that okay?
Could you come
Yes.
Sorry, Mustafa. What did you say?
back?
Questions,
Please come back to questions.
When we went when we hit number 10, number 2.
Okay, your voice is really breaking up a lot, so I did not hear a single thing you said. Can you just repeat that a little bit, please?
Could you come back, please, to the question?
Okay, yes. Which one?
For they wrote the examples. No. Question, the homework, the last one.
Oh, the homework. Okay, yes. All right. What would you like to know?
N is equal to 1, 0 or 10. Okay.
This is
what
1,
does it mean?
0. This is 1, 0. Enter M. This is 1. Enter N, 0. It's just an example.
What does it mean by number 2 exactly?
That's what I want you guys to figure out. Like, what exactly does this function do? I want you guys to figure that out. Does it sum up? Does it divide? Is it factorial? What exactly is it? If you can't figure out what exactly the program does, like I said, just kind of do the forward and backward propagation, and yeah, don't worry about it. I will kind of explain it to you next class or in the chat what exactly this program does. But yeah, I'll leave that up to you because there's nothing else apart from that. It's just pretty much plug in these functions into your program. So food for your thought. All right, is that okay?
Okay.
All right. So if there are no other questions, like I said, if you have any problems with the course stuff, I can help you guys out. I've taken this course before, so I can help you out with the questions and stuff like that if you're confused. Okay.
One question. What's the period of the submission for the homework?
I will upload that like right after the class. I will upload your assignments and add you guys and put the date and everything. But I think it's going to be where is it?
2 weeks.
probably on the 9th. Is it on the, wait, is it 9th? No, sorry. Saturday 15. Yeah, it should be on the 16th. Yes, sorry, 2 weeks. So it's gonna be on the 16th. All right. Is that okay?
Okay.
All right. Have good luck to you guys with your midterms. Study hard and see you guys later.
Excuse me. We
Yes.
are in 25. How's